What if everything we thought we knew about life in the universe was wrong? Picture this. You step outside on a clear night, staring up at countless stars, and suddenly it hits you. Some of those distant suns don't play by the rules. They don't just twinkle quietly in the void. They flicker in ways that make no sense. They vanish and reappear without warning. Some even seem to be hiding structures so enormous, so unnatural, that they defy every law of physics we've ever written. These aren't just stars, they're cosmic rebels, rewriting the textbook on what's possible. And tonight, we're going to meet 25 of them. Think about the last time you heard a fact that made your brain stutter, like realizing there are more trees on Earth than stars in the Milky Way. Now imagine that feeling, but 1,000 times stronger, because scattered across our galaxy are star systems so bizarre, they're practically shouting at us to pay attention. Take the infamous Tabby Star, for example. Astronomers caught it dimming by 22% at random intervals, as if something colossal was passing in front of it. Or the rogue planets hurtling through space alone, untethered to any sun, yet possibly harboring oceans beneath their icy shells. These aren't just curiosities. They're clues, pieces of a puzzle that could change how we define life itself. Here's why this matters. Every time we discover a star that behaves strangely, it's like the universe handing us a riddle. What if life doesn't need a warm, rocky planet like Earth? What if it thrives in the crushing depths of a gas giant or floats in the atmosphere of a dying star? The systems we'll explore today don't just challenge science, they stretch our imagination. They force us to ask, are we alone, or are we just not looking in the right places? By the time we reach the final star on this list, you might start seeing the night sky differently, not as a static backdrop, but as a living, shifting frontier where the rules are still being written. So let's begin, because out there, in the quiet darkness, something extraordinary is waiting. Let's start with the star that kicked off modern astronomy's biggest detective story, KIC 8462852, better known as Tabby Star. Nestled in the constellation Cygnus, this unassuming flicker of light made headlines when astronomers noticed its bizarre behavior. Most stars dim in predictable, rhythmic ways, often due to orbiting planets passing in front of them. But Tabby's star, it doesn't just dim, it plunges. At one point, its light dropped by a staggering 22%, as if something enormous and jagged, something unlike any planet or comet we've ever seen, was blocking its glow. Theories exploded faster than a supernova. Some scientists proposed a swarm of comets, thousands of them, crumbling as they circled the star. Others pointed to interstellar dust drifting in strange, uneven clouds. But then came the wild-card idea, the one that set the internet ablaze. What if we were seeing the shadows of alien megastructures? Imagine a civilization so advanced, they've built vast energy harvesting arrays around their star, something like a Dyson sphere. The irregular dips in light could be the silhouette of these colossal constructs, orbiting in ways no natural object ever would. Here's where it gets even stranger. Tabby Star doesn't just dim erratically, it's also been slowly fading over decades. Data dug up from old photographic plates showed its light has dropped by nearly 15% in the past century. No known natural phenomenon explains that, not comets, not dust. So what does that leave us with? Either we're witnessing an entirely new cosmic event, one that rewrites astrophysics, or we're glimpsing something even more extraordinary, the fingerprints of intelligence. But before we jump to conclusions, let's be clear: science thrives on skepticism. The truth is, Tabby Star is a reminder of how much we still don't understand. Maybe it's neither aliens nor a fluke of nature, but something in between, a phenomenon so rare we've never seen it before, and that's the real magic here. Whether it's a cosmic construction site or a celestial oddball, this star challenges us to think bigger, because if nothing else, it proves the universe still has surprises up its sleeve, and they might be closer than we think. Now let's shift our gaze to a star system that feels like it was plucked straight from a sci-fi novel, TRAPPIST-1, an ultra-cool dwarf star just 39 light-years away. At first glance, it's unremarkable, smaller, dimmer, and cooler than our Sun. But look closer and you'll find a cosmic jackpot, 7 Earth-sized worlds, 3 of them nestled snugly in the habitable zone where liquid water could exist. That's more Earth-like planets orbiting a single star than we've found anywhere else. Yet TRAPPIST-1 isn't just a checklist of potentially habitable worlds. It's a laboratory for rethinking what habitable even means. Picture standing on one of these planets. Because they orbit so close to their faint star, a year passes in just a handful of Earth days. The skies would loom with the other 6 planets, some appearing larger than our moon. But here's the catch. These worlds are likely tidally locked, meaning one side basks in eternal daylight while the other drowns in endless night. The Terminator line, the twilight zone between these extremes, could be a surreal haven where temperatures might be just right for liquid water. But life here wouldn't play by Earth's rules. Imagine organisms adapted to cling to that narrow ribbon of twilight, or ecosystems thriving beneath miles of ice on the night side, kept warm by geothermal heat. Then there's the question of atmospheres. With planets packed so tightly together, their gravitational dances could strip away or distort their air over time. Some might be barren rocks, others could harbor thick, Venus-like shrouds of gas, and if life did arise, it might rely on chemistry we've never seen, perhaps using solvents other than water, or drawing energy from the star's faint glow in ways that defy our understanding. TRAPPIST-1 doesn't just offer targets in the search for life, it shatters our assumptions. We're forced to ask, is a habitable zone too simplistic? Could life flourish in places we've dismissed as too extreme? This tiny star and its 7 worlds remind us that the universe doesn't care about our definitions. It's out there, experimenting with possibilities we've only begun to imagine. And that's what makes TRAPPIST-1 not just a curiosity, but a beacon pointing us toward a future where life as we know it might be just the beginning. Now let's travel 127 light-years away to a star system that makes our solar system look almost empty, HD 10180. At first glance, this Sun-like star seems ordinary, but its planetary family is anything but. With at least 9 confirmed worlds and possibly more waiting to be discovered, HD 10180 crams more planets into its orbit than our own solar system. Yet here's the twist, these worlds aren't spread out like ours. They're packed together in a cosmic traffic jam, defying everything we thought we knew about how planetary systems form. Take Mercury, the closest planet to our Sun. Now imagine fitting 2 more planets inside its orbit. That's the reality of HD 10180's inner system, where multiple worlds whip around their star in a matter of days. The outermost known planet still orbits closer than Venus does to our Sun. This isn't just unusual, it's a direct challenge to our models of planetary spacing. How do these worlds avoid catastrophic collisions? Gravitational simulations suggest their orbits are locked in an intricate dance, a delicate balance of pushes and pulls that keeps them stable for now. But over cosmic timescales, even this precision choreography might falter, leaving astronomers wondering, is this system on the brink of chaos, or have we stumbled upon a new kind of equilibrium? Now picture standing on one of these worlds. The night sky wouldn't just have a few wandering points of light. it would be filled with neighboring planets, some appearing as large as our moon, their surfaces illuminated by the distant glow of HD 10180. How would a civilization here view the universe? Would they see their crowded heavens as normal, or would they gaze at our thinly spaced solar system and think it eerily empty? Their very concept of planet might differ from ours, shaped by a reality where worlds are always within reach, and then there's the question of life. With planets so close together, tidal forces could heat their interiors, creating subsurface oceans even on worlds outside the traditional habitable zone. Could life hop between these neighboring planets on fragments ejected by asteroid impacts, like cosmic seeds drifting on the wind? Or would the constant gravitational tug of war render their environments too unstable? HD 10180 doesn't just test the limits of planetary science, it forces us to expand our imagination. Because if life can thrive in such a crowded, dynamic place, the galaxy might be far richer and far stranger than we ever dreamed. Dead stars aren't supposed to have planets. At least that's what we thought until we met PSRB 1257+12, a cosmic gravestone that defies the rules. This pulsar, the spinning corpse of a massive star that went supernova, should be the last place you'd find worlds. Its surface blasts out deadly radiation, its magnetic field could shred atoms, and it spins faster than a kitchen blender, 160 times every single second. Yet somehow, against all odds, this zombie star hosts not one but 3 planets. These weren't just any exoplanets, they were the first ever discovered beyond our solar system, back in 1992. And their existence forces us to ask a terrifying, thrilling question. What if life doesn't just survive in hellish places, but thrives there? Picture these worlds. They orbit so close to their undead sun that a year passes in just 25 Earth days. There's no gentle sunlight here, just a relentless hail of gamma rays and X-rays, enough to sterilize any Earth-like life in seconds. But here's where it gets fascinating. Some scientists speculate that beneath these planets' scorched surfaces, tidal forces from the pulsar's gravity could keep underground oceans liquid. And if life exists there, it wouldn't rely on photosynthesis. Instead, it might feed directly on the pulsar's radiation, using subatomic particles the way plants use sunlight. Imagine organisms with crystalline structures in their cells, tuned to absorb high-energy radiation, or microbes that treat deadly gamma bursts like a summer breeze. The real shocker, PSRB 1257+12's planets shouldn't exist at all. When their parent star exploded, the blast should have vaporized any nearby worlds. So how did they survive? One theory suggests these planets are the resurrected remains of the original system, debris from the supernova that somehow clumped back together. Another wild idea proposes they're second-generation planets, born from the ashes of the dead star itself. Either way, their presence hints that planetary formation might be far more resilient and far weirder than we imagined. This changes everything. If planets can form around stellar corpses, then the galaxy might be littered with worlds we've overlooked. And if life can emerge in the particle storm around a pulsar, then our definition of habitable is hopelessly narrow. PSRB 1257+12 doesn't just expand the cosmic real estate for life, it rewrites the playbook entirely. Because if something can live here, in this radioactive nightmare, then perhaps the universe is even more inventive than we dared to dream. Some worlds are born under a death sentence. Wasp 12b isn't just a planet, it's a cosmic tragedy unfolding in real time. This hot Jupiter orbits so close to its star that a single year lasts just 26 hours. Imagine a world where the sun doesn't rise and set. It looms monstrous and unblinking, filling half the sky with searing light. The star's gravity is so relentless, it's literally ripping the planet apart, stretching it into an egg shape while a torrent of molten material spills into space, forming a tail 3 times the size of Jupiter itself. Wasp 12b isn't just dying, it's being devoured alive. Yet here's the twist that haunts astronomers. This doomed world's atmosphere is rich in organic molecules, carbon, oxygen, even water vapor. The building blocks of life swirling in a maelstrom of destruction. It's like finding a thriving garden in the middle of a volcano. Could life, against all odds, spark into existence here, even if only for a fleeting moment? Picture organisms evolving at breakneck speed, adapting to a world where the ground melts beneath them and the sky is always on fire. Maybe microbes that feast on the very radiation tearing their planet apart, or creatures with life cycles measured in days, racing against their world's inevitable demise. The most chilling part, Wasp 12b's fate is a preview of what could happen to countless planets. In about 10 million years, a blink in cosmic time, this world will be gone, reduced to a wisp of vapor and a faint scar on its star's surface. But its existence forces us to confront a radical idea. What if life isn't always about stability? What if it's a flickering flame, burning brightest in the moments before the wind snuffs it out? Wasp 12b doesn't just challenge our search for life, it redefines the very meaning of survival. Because if life can emerge in the chaos of a disintegrating world, then the universe might be filled with ephemeral biologies, blooming like cosmic wildflowers in the brief spaces between cataclysms. And that changes everything. Suddenly, the galaxy isn't just a collection of habitable zones, it's a tapestry of moments, some fleeting, some enduring, all whispering the same question: how many ways can life fight to exist? Kepler 438b should be a dream discovery, an Earth-sized world snugly placed in its star's habitable zone, where temperatures might allow liquid water. But this planet has a dark secret. Its sun, a red dwarf named Kepler 438, isn't the gentle, steady glow we're used to. It's a cosmic tempest erupting in superflares so violent they make our sun's solar storms look like candle flickers. These aren't just occasional fireworks, they're apocalyptic events, blasting the planet with radiation doses hundreds of times stronger than anything Earth has ever experienced. So while Kepler 438b orbits in the so-called Goldilocks zone, its surface is anything but just right. Imagine standing on this world. The sky might glow an eerie red, the dim star looming large overhead. Suddenly, a flare erupts, a searing flash brighter than 1,000 suns. Within minutes, the atmosphere sizzles with X-rays and ultraviolet radiation, stripping away molecules atom by atom. Any life on the surface would be fried instantly, but here's the twist: life might still find a way. Beneath miles of ice or rock, shielded from the deadly radiation, subterranean oceans could persist. Picture microbial communities thriving near hydrothermal vents, their biochemistry adapted to harness energy from the planet's internal heat rather than sunlight. Or perhaps floating colonies in deep ocean trenches where water absorbs the worst of the stellar tantrums. What makes Kepler 438b so fascinating isn't just its hostility, it's the way it shatters our assumptions. We've long treated the habitable zone as a cosmic real estate checklist. Find an Earth-sized planet there and boom, potential life. But this world forces us to ask, is the habitable zone a myth? Red dwarfs make up 75% of stars in our galaxy, and most are flare-prone. If their planets are constantly sterilized by radiation, does that mean the majority of habitable worlds are actually dead ends? Or does it mean life, if it exists, is far more inventive than we've imagined? Kepler 438b doesn't just expand the search for life, it complicates it. Because if we're ever going to find our cosmic neighbors, we might need to stop looking for Earth twins and start searching for survivors. This planet isn't a paradise. It's a battleground, and the fact that it exists at all forces us to confront a humbling truth. The universe doesn't care about our definitions of habitable. It's out there playing by its own rules, and life, if it's clever enough, might just find a way to keep up. LHS 1140b isn't your typical super-Earth. This dense, rocky giant, nearly 7 times heavier than our planet, orbits a dim red dwarf star 49 light-years away, close enough that its secrets could one day be within our grasp. At first glance, it seems like another frozen wasteland, locked in permanent twilight, but peer beneath its icy crust, and you'll find something extraordinary. A hidden ocean kept liquid by the planet's own internal heat, sloshing beneath miles of ice. This isn't just a theoretical possibility. The chemistry of LHS 1140b's atmosphere hints at active geology, volcanoes spewing gases, hydrothermal vents pumping warmth into the abyss. In other words, this world might be a snowball on the outside, but a cauldron of potential life on the inside. Picture this alien sea. No sunlight ever reaches it. The ice ceiling above is so thick it crushes with pressures beyond human comprehension. Yet around volcanic vents, minerals dissolve into the water, creating a broth of chemicals ripe for life. On Earth, we've found entire ecosystems thriving in such places: tube worms, blind shrimp, microbes that eat sulfur or methane. Now imagine organisms adapted to even stranger conditions. Creatures with antifreeze in their veins, or cells powered not by photosynthesis, but by the steady pulse of geothermal energy. Their world would be eternally dark, yet far from dead, a labyrinth of warm pockets and mineral-rich currents, a biosphere hidden from the universe. What makes LHS 1140b so revolutionary isn't just its ocean. It's the way it forces us to rethink the term habitable. We've long assumed life needs a sunlit surface, a gentle climate, an Earth-like balance. But this planet whispers a different truth. Life might flourish in the unlikeliest pockets, in places where the very idea of a surface is irrelevant. If entire ecosystems can exist cut off from stars, then the galaxy's real treasure trove of life might not be in the Goldilocks zone. It could be buried in the frozen dark, waiting for us to dig deeper. And here's the kicker: LHS 1140b star is calm for a red dwarf. No violent flares, no atmosphere-stripping tantrums. That stability means any subsurface ocean could have persisted for billions of years, plenty of time for life to arise, evolve, and perhaps even grow complex. Which raises a haunting question: if intelligent beings exist beneath that ice, would they even know they're on a planet? To them, the universe might be nothing but rock, ice, and the warmth beneath their feet. The concept of stars, of space, of other worlds, all of it could be as alien to them as their existence is to us. This is the real gift of LHS 1140b. It doesn't just add another candidate to the list of potentially habitable worlds. It shatters the list entirely, reminding us that life isn't a checkbox of conditions. It's a phenomenon stubborn enough to emerge in the cracks of impossibility. So the next time you hear about a frozen exoplanet, don't dismiss it. The most vibrant worlds might be the ones we can't even see. From a distance, HD 189733b looks almost inviting. A serene, deep blue orb that wouldn't seem out of place in a watercolor painting of the cosmos. But get closer and the illusion shatters. This isn't the blue of Earth's oceans or a hazy atmosphere. It's the blue of a blowtorch flame, a warning written in light. Here, the skies aren't filled with water vapor, but with clouds of silicate particles, tiny shards of rock, vaporized by temperatures soaring to 1,700 degrees Fahrenheit. And when these clouds condense, they don't produce raindrops. They unleash storms of molten glass, hurled sideways by winds screaming at 5,000 miles per hour. This isn't just a hostile planet, it's a nightmare rendered in sapphire. Yet within this fury lies a tantalizing mystery. Silicates, the same minerals that form the bulk of Earth's crust, are here behaving in ways we've never seen. On our planet, silica becomes glass under extreme heat and pressure. But on HD 189733b, it doesn't just melt. It becomes part of a chaotic, churning atmosphere, cycling between gas, liquid, and solid in a relentless, hellish loop. And that raises a radical question. Could this very violence be a cradle for complexity? On Earth, life emerged in the turbulent chemistry of hydrothermal vents. Could a similar process unfold here, not with water, but with liquid metal and plasma? Imagine a form of life built not on carbon, but on silicon chains, thriving in superheated storms. Organisms might draw energy from the planet's violent wind shear, or the electrical charges crackling through its glass-laden skies. Their bodies could resemble crystalline structures, constantly reforged in the furnace of their world. Far-fetched, perhaps, but remember every extreme environment we've discovered on Earth, from acidic hot springs to crushing ocean trenches, teems with life we once thought impossible. HD 189733b forces us to confront the unsettling truth. Our definition of life might be laughably limited. What makes this world truly transformative isn't just its brutality, it's the way it redefines the canvas of habitability. We've long assumed life needs gentle temperatures, stable chemistry, and solvents like water. But here, in a realm where the very air is weaponized, the rules might be written in molten glass. And if that's the case, then the galaxy's potential for life isn't just broader. It's stranger, wilder, and more exhilarating than we ever dared to dream. HD 189733b doesn't just challenge our search for life. It dares us to rethink what life even is. Kepler 1649c is the cosmic equivalent of finding a perfectly preserved flower in the middle of a battlefield. Buried in old telescope data, this unassuming world first slipped past detection algorithms until a sharp-eyed researcher noticed what the machines had missed. A rocky planet barely 6% larger than Earth, basking in sunlight eerily similar to our own. On paper, it checks every box for habitability, but here's the catch: it orbits a red dwarf, the most temperamental star type in the galaxy. These stars are notorious for unleashing apocalyptic flares, bombarding nearby planets with enough radiation to strip atmospheres bare. Yet somehow, against all odds, Kepler 1649c persists not as a charred husk, but as a potential oasis. So how does it survive? The answer might rewrite planetary science. Most red dwarf planets are tidally locked, with one side perpetually scorched and the other frozen. But Kepler 1649c's orbit is just eccentric enough, slightly oval rather than perfectly circular, to possibly generate internal heat through gravitational flexing. This could power a magnetic field strong enough to deflect deadly stellar winds, or even drive plate tectonics to recycle its atmosphere. Then there's the atmosphere itself. If it's thick with carbon dioxide, it might act like a cosmic shock absorber, dispersing the energy of flares across the planet rather than letting it concentrate in lethal bursts. Now picture life on this world. The surface might experience sudden, searing flashes as flares hit, but beneath a protective atmospheric blanket, organisms could have evolved to sense these events like we sense thunderstorms, retreating into burrows or water when the sky ignites. Plants might photosynthesize in frantic bursts between flares, or use infrared light from the dim star more efficiently than Earth's vegetation. And if the planet has active geology, hydrothermal vents could harbor entire ecosystems untouched by the chaos above, much like our deep-sea extremophiles. What makes Kepler 1649c revolutionary isn't just its defiance of expectations, it's the hope it offers. If a world this stable exists around a red dwarf, then the galaxy's most common stars might host far more habitable real estate than we thought. Suddenly, billions of once-dismissed systems re-enter the search for life. This planet doesn't just challenge our models, it hands us a key. Because if we can unravel its secrets, we might find that life isn't the exception in this universe. It's the rule hiding in plain sight, waiting for us to look beyond our assumptions. Gleezer 581 doesn't just host planets, it hosts a paradox. 20 light-years away, this faint red dwarf star cradles not one, but two worlds straddling the razor's edge between habitable and hostile. Gleezer 581c, the inner candidate, basks in sunlight stronger than Earth's. At first glance, it seems perfect until you realize its atmosphere, if it exists, might trap heat like a runaway greenhouse, turning the surface into a pressure cooker more brutal than Venus. Meanwhile, its sibling, Gleezer 581d, lingers at the outer fringe of the habitable zone, where weak starlight could leave it frozen solid. Yet both planets share something extraordinary. They exist in that tantalizing space where liquid water could persist, if just the right conditions align. This is where the controversy ignites. Early studies suggested Gleezer 581d might have a thick carbon dioxide atmosphere, acting like a thermal blanket to keep subsurface oceans liquid beneath miles of ice, a snowball with a hidden heartbeat. But others argued tidal forces from the star could lock the planet's rotation, leaving one side scorched and the other in eternal darkness, with only a sliver of twilight offering refuge. The debate grows fiercer with Gleezer 581c. Some models show it as a water world, its entire surface a boiling ocean steaming under a dense atmosphere. Others paint it as a dried-out husk, its water long since vaporized into space. What makes this system revolutionary isn't the answers, it's the questions. Gleezer 581 forces us to confront the messy reality that habitable isn't a yes or no checkbox. It's a spectrum, a sliding scale of maybes. A planet might be too hot for Earth-like life, but perfect for extremophiles thriving in acidic pools. Another could be frozen at the surface, but bubbling with geothermal vents below. The line between too harsh and just right isn't just blurry. It might be different for every biosphere the universe dreams up. Consider the implications. If life can cling to existence at both the inner and outer edges of a star's habitable zone, then the real estate for biology expands exponentially. Suddenly, planets we once dismissed as marginal, too cold, too hot, too unstable, become frontrunners in the search. Gleezer 581 whispers a radical idea. Perhaps we've been too rigid in our search for Earth twins. The most alien life might not live in Goldilocks conditions at all. It might flourish in the extremes, rewriting the rules of what survival even means. And here's the twist that lingers. Gleezer 581's planets might not even be the end of the story. Later studies hinted at more worlds in the system, some potentially nestled even deeper in the star's temperate sweet spot. But the true lesson here isn't about counting planets, it's about humility. Every time we think we've pinned down the recipe for habitability, a system like this comes along to remind us the universe doesn't do recipes, it experiments. And somewhere in that cosmic laboratory, life might be thriving in ways we're only beginning to imagine. Kepler 186f isn't just another exoplanet. It's a mirror held up to our assumptions, showing us how narrow our vision of life truly is. Nestled in the constellation Cygnus, this world made history as the first Earth-sized planet ever found orbiting comfortably within its star's habitable zone. But comfortable is a relative term here. Its sun, a red dwarf called Kepler 186, is cooler and dimmer than our own, casting a faint crimson glow over the planet's surface. The light that reaches Kepler 186f is weaker, redder, fundamentally different from the golden rays that power Earth's ecosystems, and that difference changes everything. Picture a forest on this distant world. Forget the lush greens of our home planet here. Plants might evolve to absorb infrared light, their leaves tuned to harvest energy from wavelengths invisible to our eyes. Scientists speculate these alien flora could appear deep purple or even jet black to our gaze, their pigments optimized for a sun that shines more like a dying ember than a blazing fire. Imagine walking through a landscape where the vegetation is darker than charcoal, yet thrums with life, converting feeble starlight into sustenance through chemistry we've barely begun to understand. But the challenges don't end with light. Kepler 186f's orbit is likely tidally locked, meaning one hemisphere bakes in eternal daylight while the other languishes in endless night. The Terminator line, the twilight zone between these extremes, could be a narrow belt of habitability where temperatures allow liquid water to pool. Yet even here, the rules of weather would defy earthly logic. Winds might howl ceaselessly, racing to redistribute heat from the scorching dayside to the frozen nightside, creating storms that never end. What makes this planet so transformative isn't just its strangeness, it's the way it forces us to confront the flexibility of life. We've long assumed photosynthesis requires conditions like Earth's, bright sunlight, liquid water, temperate climates, but Kepler 186f whispers a different truth. Life, if it exists here, would have rewritten the playbook, finding ways to thrive in light so dim it would leave Earth's plants starving. It's a reminder that biology doesn't care about our expectations. It adapts, it persists, and sometimes it flourishes in ways we're only beginning to imagine. The real magic of Kepler 186f lies in its quiet rebellion. It doesn't scream its potential like some watery super-Earth or flare-battered rogue planet. It simply exists, a testament to the universe's boundless creativity. And in doing so, it offers us a gift, the realization that life's true color might not be green at all. It could be any hue, any shade, any adaptation that works, because in the end, life isn't about fitting our definitions. It's about surviving against all odds in whatever form the universe allows. 55 Cancry E isn't just a planet. It's a cosmic alchemist's masterpiece, a world where the line between fantasy and reality blurs into something extraordinary. Imagine standing on a surface where the ground beneath your feet isn't rock, but layer upon layer of compressed diamond, forged in the crushing pressures of a carbon-rich interior. This isn't science fiction. It's the staggering reality of a super-Earth orbiting so close to its star that a year flashes by in just 18 hours, its surface scorched to nearly 4,000 degrees Fahrenheit. Yet within this inferno lies a paradox: oceans. Not the liquid water we know, but something far stranger, a supercritical fluid, a state where the distinction between liquid and gas vanishes entirely. Picture an ocean that doesn't behave like any on Earth. Here, under blistering heat and relentless stellar radiation, water exists in a chimeric form, dense as a liquid but flowing like a gas. It clings to the planet's surface in a shimmering, unstable veil, dissolving minerals and carbon compounds with eerie efficiency. If life exists in this chaos, it wouldn't rely on the chemistry we recognize. Instead of DNA, organisms might encode information in the very structure of diamond lattices. They're cells built from interconnected carbon frameworks, resilient enough to withstand temperatures that would vaporize earthly life in an instant. The implications are dizzying. On Earth, carbon is the backbone of biology, but on 55 Cancry E, it could be the entire foundation. Scientists speculate that beneath the planet's diamond crust, tectonic forces might squeeze carbon into vast crystalline sheets, creating subterranean forests of gemstone structures. Could these formations evolve complexity? Could they store energy, replicate, even communicate? It's a radical thought, but not impossible. After all, life on Earth arose from simple chemical reactions in hydrothermal vents. Who's to say the same couldn't happen in a diamond-rich furnace, where carbon's versatility takes center stage? Then there's the enigma of those supercritical oceans. On our planet, supercritical fluids are used in industrial processes to dissolve materials ordinary liquids can't touch. But here, they might serve as the universal solvent for an entirely alien biosphere. Imagine organisms that breathe by absorbing dissolved carbon from the chaotic broth around them, their metabolisms tuned to the erratic dance of pressure and heat. Their world wouldn't have a solid surface or a clear sky, just a hazy, ever-shifting boundary between ocean and atmosphere, where existence is a perpetual tightrope walk between vaporization and crystallization. 55 Cancry E doesn't just challenge our search for life, it explodes the very framework. If biology can emerge in a diamond crucible, then the building blocks of life might be more universal than we thought. Carbon is carbon, whether it's in a protein or a gemstone, and that realization changes everything. Suddenly, the most hostile worlds become candidates. The universe, it seems, isn't just a place where life clings to comfort. It's a forge hammering out possibilities in the most unexpected corners. So the next time you gaze at a diamond sparkle, remember, somewhere out there, an entire planet might be proof that the rarest things on Earth are anything but rare in the cosmos. Kepler 22b isn't just another exoplanet, it's a revelation wrapped in liquid mystery. When astronomers confirmed its existence in 2011, it became the first world ever discovered orbiting comfortably within its star's habitable zone, a place where temperatures could allow water to pool on the surface. But this isn't just a planet with oceans, it's a planet that might be an ocean. A super-Earth 2.5 times wider than our home, Kepler 22b could lack continents entirely. Its entire surface a single, unbroken expanse of water hundreds of miles deep. Imagine a world with no mountains, no deserts, no forests, just endless waves stretching from pole to pole. An aquatic universe where the very concept of land is as alien as the void between stars. Now picture life evolving in this boundless sea. On Earth, intelligence arose in creatures that crawled onto shores, harnessing fire and stone to build civilizations. But here, fire is impossible. Metal sinks. The tools that shaped human history, axes, wheels, forges, would be useless in a realm where everything floats, drifts, or dissolves. Instead, a truly intelligent species on Kepler 22b might master the chemistry of life itself, weaving living tissues into tools and structures. Think of jellyfish-like beings engineering coral-like biocities that rise from the depths, or colonies of organisms communicating through bioluminescent pulses, their knowledge stored in the genetic code of symbiotic algae. Their technology wouldn't be built, it would be grown, and the scale of this ocean changes everything. Earth's deepest trench, the Mariana Trench, plummets 7 miles down. Kepler 22b's abysses could run hundreds of miles deep, with pressures so immense that water behaves in ways we've never seen. Down there, liquid might freeze into exotic forms of ice, not the familiar flakes of Earth, but dense, hot crystals that form under crushing weight. Yet even in these alien depths, life could thrive around hydrothermal vents, where minerals spew from the planet's core. Entire ecosystems might exist in total darkness, their biology fueled by chemosynthesis, their bodies adapted to pressures that would flatten a submarine like a soda can. What makes Kepler 22b so revolutionary isn't just the possibility of life, it's the way it shatters our Earth-centric imagination. We assume intelligence requires hands to build, eyes to see, land to conquer. But in an ocean without end, evolution might craft minds that perceive currents like we perceive landscapes, or communicate through shifts in water pressure instead of sound. Their history could be written in the slow drift of ocean currents, their cities transient constellations of living light. Kepler 22b forces us to ask, is human-like intelligence the rule, or just one fluke in a universe of possibilities? Because if civilizations can rise without fire, without metal, without ever knowing solid ground, then the galaxy might hum with voices we don't even know how to hear. And that's the real gift of this water world, not just expanding the map of where life could be, but redefining what life could become. Just 4 light years from Earth, practically next door in cosmic terms, Proxima Centauri b hangs in perpetual twilight, a world caught between fire and ice. Orbiting the smallest star in the Alpha Centauri system, this rocky planet is tidally locked, one face forever scorched by its crimson sun, the other plunged in endless night. But here's what makes it extraordinary. Despite enduring solar flares so violent they'd strip Earth's atmosphere bare in hours, Proxima b might still cradle life. Not on the surface where radiation scours the landscape, but beneath it, in vast, hidden oceans kept liquid by the planet's own internal heat, or in labyrinthine caves shielded from the fury above. Picture standing on the day side of Proxima b. The star looms 10 times larger than our Sun, appears from Earth, casting a blood-red glow over a scorched wasteland. Temperatures could soar to hundreds of degrees, hot enough to melt lead, but venture toward the Terminator line, the razor-thin border between light and dark, and conditions might grow eerily temperate. Here, in this eternal dusk, pockets of atmosphere could pool, trapping just enough warmth for liquid water to cling to rocky outcrops. Some scientists even speculate about sprawling glaciers on the night side, where subterranean heat melts the ice from below, creating sprawling underground lakes. Then there's the flares. Proxima Centauri is a tempestuous star, prone to eruptions that unleash bursts of X-rays and ultraviolet radiation 100 times stronger than anything our Sun produces. These aren't just storms, they're atmospheric apocalypses capable of shredding molecules apart. Yet life, if it exists here, might have adapted in ways we've never imagined. Deep underground, microbes could feed on radiation-resistant minerals, or harness the star's fury through exotic biochemistry. Some extremophiles on Earth thrive in nuclear reactors. Why couldn't Proxima b's organisms do the same? What makes this world so tantalizing isn't just its potential, it's the possibility that we might actually visit it within our lifetimes. Breakthrough Starshot, a project aiming to send tiny probes to Alpha Centauri at 1/5 the speed of light, could reach Proxima b in just 20 years. Imagine photographs of an alien Terminator line, data from its atmosphere, even signs of biosignatures, all from a planet close enough that its star is visible to the naked eye from Earth. Proxima Centauri b isn't just a scientific curiosity, it's a mirror held up to our own cosmic loneliness. After centuries of wondering if we're alone, the answer might be hiding practically in our backyard, not on a distant, frozen world, but on a planet so near, its whispers could already be reaching us. We just have to learn how to listen. TOI 700d defies everything we thought we knew about stable planets. Nestled in a triple star system 31 light-years away, this rocky world doesn't just orbit a single sun, it dances with three. While its primary star, TOI 700, is a calm red dwarf, the other two stars whirl through the system like cosmic partners in a chaotic waltz. The result, a planet where the very definition of day and night gets rewritten by the minute. Imagine stepping onto its surface. One moment, you're bathed in the dim crimson glow of the red dwarf. The next, a second star rises smaller, cooler, casting eerie double shadows. And then, without warning, the third star streaks across the sky, a fleeting burst of brilliance before vanishing again. This isn't just a planet with three suns. It's a world where the rules of time and light are in constant flux. The gravitational tug of war between these stars creates a climate unlike anything on Earth. Seasons wouldn't follow predictable patterns, they'd lurch between extremes as the stars shift positions. Warm periods could give way to sudden frosts when a distant star's pull alters the planet's tilt. Rivers might freeze and thaw in erratic cycles, while plants would need to photosynthesize under wildly varying light intensities. Yet here's the astonishing part. TOI 700d sits snugly in its primary star's habitable zone, with temperatures that could allow liquid water. So how would life adapt to such chaos? Picture organisms with biology so flexible, it borders on science fiction. Plants might evolve leaves that change shape to capture different wavelengths of light, depending on which star dominates the sky. Microbes could lie dormant for years, only to explode into activity when conditions briefly align. And predators, they'd need strategies to hunt across landscapes where temperature swings redefine the meaning of habitat by the hour. This isn't just survival of the fittest, it's survival of the most adaptable, where rigidity means extinction. What makes TOI 700d revolutionary isn't just its triple-star ballet, it's the way it forces us to rethink life's resilience. We've always assumed stable orbits and consistent climates were prerequisites for habitability. But this planet whispers a different truth. Life might flourish in the universe's noisiest, most unpredictable corners. And if that's the case, then multi-star systems, once written off as too unstable, could be hiding more gems like this one. The real lesson here isn't about finding another Earth. It's about realizing that life, in its infinite creativity, might not need an Earth at all. TOI 700d doesn't just expand the map of where we should look, it tears up the map entirely and asks us to start drawing anew. Kepler 452b isn't just another exoplanet. It's a time capsule from a future Earth might never see. Orbiting a sun-like star 1,400 light-years away, this world has spent 6 billion years basking in its star's habitable zone. That's 2 billion years longer than Earth has even existed as a life-bearing planet. To put that in perspective, if Kepler 452b developed intelligence at the same pace we did, its civilizations would have had an extra 2 billion years to evolve, invent, and perhaps outgrow the very need for biology as we know it. Standing on this planet's surface, assuming it has one, would feel eerily familiar yet profoundly alien. Its sun, Kepler 452, is 20% brighter and 10% larger than ours, casting a golden-white glow over landscapes that might resemble Earth. If Earth had undergone billions more years of geological and biological upheaval, rivers could have carved canyons so deep they dwarf the Grand Canyon. Continents might have merged and split dozens of times, erasing all traces of their original shapes. And life, if it arose here, it could have cycled through countless evolutionary experiments, some succeeding, others vanishing into the fossil record of a world with unimaginably long chapters. The real mind-bender isn't just the age of this planet, it's what could have happened there by now. On Earth, modern humans have existed for a mere 200,000 years, a blink in cosmic time. Yet in that sliver, we've gone from stone tools to quantum computers. Now stretch that progress over 2 billion extra years. A civilization with that kind of head start might have mastered technologies that seem like magic to us, harnessing the energy of black holes, engineering self-replicating megastructures, or even transcending physical form altogether. Some theorists suggest such beings could have become post-biological, their consciousness uploaded into quantum networks or distributed across interstellar clouds of nanomachines. But here's the haunting flip side. If intelligence did arise on Kepler 452b, why haven't we heard from it? The Fermi paradox, the unsettling silence of the cosmos, grows even louder when applied to a world this ancient. Perhaps civilizations that old inevitably self-destruct, their technologies outpacing their wisdom. Or maybe they've evolved beyond the need to expand or communicate, retreating into inner worlds of simulation so advanced, reality itself becomes irrelevant. Then again, the simplest answer might be the most humbling. Life, even given billions of years, isn't guaranteed to produce intelligence at all. Maybe this planet is a garden of microbes, or a paradise where multicellular life never took the leap to complexity. Kepler 452b doesn't just expand the search for life, it holds up a mirror to our own future. If Earth lasts another billion years, will we still recognize it? Will we still be here, or will we have become something else entirely? This distant world whispers a truth we're only beginning to grasp. Time is the universe's most potent alchemist. And given enough of it, even the wildest possibilities become inevitable. GJ1214b doesn't just push the boundaries of what we consider habitable, it smashes them entirely. This steamy water world, 48 light-years away in the constellation Ophiuchus, is shrouded in a thick hydrogen atmosphere so dense it acts like a pressure cooker, trapping heat and bending the very laws of physics. Beneath that oppressive veil lies something even more extraordinary, an ocean deeper than Earth's entire crust, where water doesn't behave like water at all. Here, under pressures 200,000 times stronger than our planet's surface, H2O transforms into exotic states known as hot ice, solids that remain frozen despite temperatures hot enough to melt lead. Now picture life in this alien abyss. On Earth, extremophiles thrive near hydrothermal vents, unfazed by crushing depths and scorching heat. But GJ1214b's organisms, if they exist, would face conditions so extreme they'd make Earth's deep sea vents look temperate. Enzymes here might evolve to function in superheated ice, their molecular structures reinforced by the relentless pressure. Metabolism could rely not on oxygen, but on chemical reactions between water and the planet's hydrogen-rich atmosphere, creating an energy cycle utterly foreign to our own. Some scientists speculate that life in such an environment might resemble gelatinous mats, their bodies more like dense gels than cellular organisms, able to withstand pressures that would instantly crush Earth's toughest deep-sea creatures. What makes this world revolutionary isn't just its hostility, it's the way it redefines the galactic census of life. For decades, we've hunted for Earth twins, assuming rocky planets with thin atmospheres were the only viable homes for biology. But GJ1214b suggests something radical. Mini-Neptunes, long dismissed as gas-shrouded dead ends, might be the universe's most common abodes for life. Their thick atmospheres could shield subsurface oceans from radiation, while internal heat keeps those waters liquid for billions of years. Imagine entire civilizations evolving in perpetual darkness, their skies forever hidden by swirling hydrogen, their histories written in the slow churn of pressurized tides. Then there's the chemistry. On Earth, life relies on carbon dissolved in water, but GJ1214b's ocean might be laced with ammonia, methane, or even silicon compounds, creating a broth where entirely new biological architectures could arise. Picture organisms with circulatory systems filled with liquid diamond, forged in the ocean's crushing depths, or colonies of creatures that communicate through pulses of pressure waves, their language indecipherable to any surface-dwelling species. The most humbling lesson of GJ1214b isn't just about alien life, it's about our own blind spots. We've spent centuries imagining life as a reflection of Earth's conditions. But this world whispers a truth we're only beginning to grasp. The universe doesn't care about our assumptions. It invents, experiments, and thrives in ways we've yet to imagine. And if places like this can harbor life, then the cosmos might not be a lonely desert after all, but a crowded, whispering ocean, waiting for us to learn how to listen. HD 80606b doesn't just have seasons, it has planetary mood swings so violent they make Earth's winters and summers look like a mild breeze. This gas giant, 200 light-years away in the constellation Ursa Major, follows an orbit so stretched and lopsided it would make a comet blush. At its farthest point, it drifts lazily, basking in the gentle warmth of its star. But when it swings close, temperatures skyrocket by over 1,000 degrees Fahrenheit in a matter of hours. Imagine a world where spring doesn't arrive in gentle blossoms, but in a blistering, atmosphere-shredding inferno where summer isn't a season, but a cataclysm. Now picture life trying to survive in this chaos. On Earth, animals migrate to avoid harsh winters or scorching droughts. But on HD 80606b, migration wouldn't be a choice, it would be a matter of life and death. Any organisms clinging to existence here would need to evolve strategies far beyond anything we've seen. Perhaps vast, floating ecosystems drift with the planet's jet streams, surfing the thermal waves between scorching daysides and frigid nightsides. Or maybe life burrows deep into the planet's layers, lying dormant for months until the orbit brings tolerable temperatures back. The most radical idea. Intelligent beings could have developed nomadic civilizations, entire cultures built around constant movement, their cities designed to fold, unfold, or even fly as the climate shifts beneath them. The planet's atmosphere tells its own horror story. As HD 80606b approaches its star, the sudden heat triggers supersonic storms, with winds screaming at over 10,000 miles per hour, fast enough to circle Earth twice in a single day. These aren't just weather events, they're atmospheric convulsions reshaping the planet's very structure with each orbit. Yet even in this turmoil, scientists have detected traces of water vapor and organic molecules. It's a tantalizing hint that, against all odds, the building blocks of life might persist here not in spite of the chaos, but because of it. What makes this world so transformative isn't just its extremes, it's the way it forces us to rethink resilience. We've always assumed life needs stability, steady orbits, predictable climates, gentle transitions. But HD 80606b whispers a different truth. Life might thrive in the universe's most turbulent corners, adapting to rhythms we can barely comprehend. If that's the case, then habitable doesn't mean calm. It means versatile, and that's the real revelation. This planet isn't just a curiosity, it's a challenge. A reminder that the universe doesn't play by our rules. Out there, in the swirling madness of elliptical orbits and supersonic storms, life might be rewriting the playbook in ways we're only beginning to imagine. So the next time you complain about a heat wave or a cold snap, remember, somewhere out there, a world is turning seasons into an extreme sport, and life, against all odds, might be keeping pace. Kepler 1647b isn't just another gas giant, it's a cosmic matryoshka doll hiding staggering possibilities within its orbit. Clocking in at nearly the size of Jupiter, this colossal planet holds a record, the largest world ever found sitting squarely in its star's habitable zone. But here's the twist that rewrites the search for life. The real treasures here might not be on the planet itself, but around it. Imagine Earth-sized moons, not just one but potentially several, each with its own stable climate, orbiting this gentle giant like a miniature solar system in its own right. These wouldn't be dead rocks like our moon, they could be vibrant worlds with thick atmospheres, deep oceans, and even continents, all kept warm by the gravitational tug of war between their massive parent planet and the distant sun. Picture standing on the surface of such a moon. The sky would be dominated by the looming curve of Kepler 1647b, its swirling bands of gas filling half the heavens. Tidal forces from the giant could heat the moon's core, powering volcanic activity and creating geothermal hotspots, perfect nurseries for life. Meanwhile, the distant sun, smaller and dimmer than ours, would cast a pale glow over landscapes where seasons last for years. The moon's own rotation, combined with its orbit around the gas giant, could create day-night cycles far more complex than Earth's, with periods of eternal twilight as it passes through the giant's shadow. What makes these exomoons such tantalizing candidates for life isn't just their potential for liquid water, it's their stability. Gas giants act like cosmic shields, their massive gravity deflecting asteroids and comets that might otherwise bombard their moon. And while planets in habitable zones can suffer extreme temperature swings as their stars age, moons benefit from the steadying influence of their giant hosts, maintaining consistent climates for billions of years. It's the best of both worlds, the gravitational protection of a gas giant paired with the temperate conditions of the habitable zone. Then there's the diversity. A single gas giant could host multiple moons, each with radically different environments. One might be a frozen world with subsurface oceans, another a steamy jungle moon, and yet another a desert orb with vast salt flats. If life arises on one, it might spread to the others via meteorite impacts, creating an interconnected web of biospheres orbiting the same planet. The evolutionary possibilities are mind-bending. Imagine flying creatures adapted to the thick atmospheres of one moon swimming through the hydrocarbon lakes of another during inter-moon migrations. Kepler 1647b shatters the planetary-centric view of habitability. For centuries, we've imagined life clinging to the surfaces of Earth like worlds. But this system whispers a different truth. The universe might prefer to build its oases in the shadows of giants. And if that's the case, then the galaxy's most vibrant life might not be on planets at all, but in the skies above them, dancing in the glow of their colossal guardians. Wolf 1061c doesn't just orbit its star, it rides a roller coaster of cosmic extremes. 14 light-years away in the constellation Ophiuchus, this super-Earth swings around its dim red dwarf on an elliptical path so stretched that its seasons don't gently transition, they plunge. One moment the planet basks in relative warmth, its oceans liquid and skies clear. The next, it spirals outward into a deep freeze so severe that even the atmosphere might collapse into frost. These aren't subtle shifts. They're planetary convulsions cycling between greenhouse and icehouse states with brutal efficiency. Yet within this chaos lies a provocative question. Could such instability be the ultimate crucible for intelligence? Picture a civilization rising on this unpredictable world. With climate swings spanning millennia, survival wouldn't just be about adaptation, it would demand anticipation. Cultures might develop mythologies around orbital patterns, treating their star's erratic dance as a deity to be appeased. technology would race ahead not for convenience but for sheer necessity. Imagine cities built to fold underground during ice ages, or vast orbital mirrors deployed to deflect sunlight during scorching periastron passages. The very concept of progress here wouldn't be linear, it would be cyclical, with each golden age followed by a desperate scramble to preserve knowledge through the next freeze. The planet's geology likely mirrors this turbulence. Tidal forces from its elliptical orbit could churn the mantle, fueling relentless volcanic activity. Eruptions might temporarily warm the surface during glacial peaks, creating brief oases where life clings on. Subsurface oceans, insulated by miles of ice, could harbor extremophiles that migrate upward during thaws, seeding the surface with each orbital spring. And if intelligence did emerge, its greatest challenge wouldn't be war or resource scarcity, it would be time. How do you build a civilization when your environment resets itself every few thousand years? Wolf 1061's real lesson isn't about the fragility of life, it's about resilience. On Earth, stable climates allowed intelligence to develop slowly, over millions of years. But here, survival might demand rapid innovation, compressing technological leaps into narrow windows of habitability. A species facing extinction every orbit wouldn't have the luxury of stagnation. They'd need to master fusion, geoengineering, or even interstellar travel not as ambitions but as lifelines. This world shatters the myth that habitable means stable. What if the universe's most advanced civilizations aren't the ones cradled by gentle suns, but those forged in chaos? Wolf 1061c whispers a radical idea. Sometimes the hardest environments don't stifle intelligence, they accelerate it. And that changes everything, because if survival against impossible odds is the catalyst for greatness, then the galaxy might be far louder, far brighter than we ever imagined. Kepler 62f isn't just another exoplanet, it's a watercolor painting of an alien paradise. A world where the line between science and dreams blurs into something extraordinary. Imagine standing on the shores of a vast, shallow sea, the horizon stretching farther than on Earth, the sky tinged peach by the light of a cooler, older sun. This super-Earth, 40% larger than our home planet, could be dotted with archipelagos of volcanic islands, their coastlines smoothed by gentle tides from a moon we haven't even detected yet. But what truly sets Kepler 62f apart isn't just its potential for water, it's how its size reshapes the very possibilities of life. That extraplanetary mass comes with consequences. Gravity here would be nearly twice as strong as Earth's, turning every step into a calculated effort. Trees might grow stockier, their trunks thicken to withstand the relentless pull. Animals could evolve with denser bones and more muscular builds, their bodies optimized for a world where falling carries greater risk. Picture a predator not unlike a terrestrial bear, but with limbs like hydraulic pistons, capable of explosive bursts of speed to compensate for the gravity's drag. Or herbivores with column-like legs, moving in slow motion through fields of ultra-rigid grasses. Even the simplest organisms would face new challenges. Insects, if they exist here, might abandon flight altogether, their wings unable to overcome the atmospheric pressure near the surface. Yet this heightened gravity could also spark evolutionary wonders. In Earth's oceans, buoyancy allows creatures like whales to grow massive despite their weight. On Kepler 62f, shallow seas might become nurseries for life forms that use water's lift to counteract gravity's grip, leading to aquatic species of staggering size and complexity. Imagine coral-like structures so vast they form underwater mountain ranges, or filter feeders with bodies the length of blue whales but with intricate, lattice-like skeletons to distribute their weight. And what of intelligence? A species evolving in this environment might develop unique problem-solving skills, not for crafting tools to hunt, but for engineering solutions to move efficiently in a world that constantly fights back. The planet's star adds another layer of intrigue. Kepler 62 is smaller and dimmer than our Sun, bathing its planets in reddish light. Photosynthetic organisms here wouldn't chase the yellow wavelengths Earth's plants rely on. They might evolve to harness infrared, their leaves appearing deep burgundy or even black to our eyes. And with years lasting just 267 Earth days, seasons would flicker by in rapid succession, possibly driving life cycles faster than we're used to. Predators and prey could engage in an endless arms race, their adaptations cycling at a pace that would leave Darwin dizzy. What makes Kepler 62f so revolutionary isn't just its checklist of habitable traits, it's the way it forces us to confront our Earth-centric biases. We assume intelligence requires opposable thumbs or flight, but on a high-gravity world, the pinnacle of cognition might belong to a slow-moving, six-limbed philosopher navigating tidal pools with a brain wired for hydrodynamics. Or perhaps a colonial organism, its intelligence distributed across a networked swarm, communicating through bioluminescent pulses in the planet's twilight shallows. This world doesn't just expand the search for life, it explodes the canvas. Suddenly, a galaxy of possibilities opens up, not just Earth twins, but super-Earths with towering biology, orbs where evolution paints with colors we've never seen. Kepler 62f isn't a footnote in the hunt for habitable planets. It's a reminder that the universe's imagination dwarfs our own, and that life, in all its forms, might be far more creative than we've ever dared to dream. K218b isn't just another exoplanet. It's a glimpse into a universe where the recipe for life might not need a single ingredient we consider essential. Floating 124 light-years away in the constellation Leo, this mysterious world belongs to an entirely new class of planets, Heisian worlds. The name alone sounds like something from a sci-fi novel. Hydrogen-rich atmospheres stretched over global oceans so vast they make Earth's seas look like puddles. But here's what makes K218b revolutionary. It's the first of its kind where we've detected water vapor swirling in its skies, not just traces either. Enough to fill entire textbooks with questions about how life could thrive in an environment this alien. Picture standing on the shores of this planet's ocean, if shores even exist. Beneath a pinkish sky choked with hydrogen, the water stretches to every horizon, unbroken by continents. The air presses down with crushing force, dozens of times thicker than Earth's, yet somehow it doesn't smother the sea below. Instead, that immense atmosphere acts like a cosmic pressure cooker, trapping heat so efficiently that even in the frigid depths of space, the ocean stays liquid. But this isn't the water we know. Dissolved in it could be ammonia, methane, or even organic compounds, creating a broth where chemistry follows rules we've barely begun to decode. And then there's the life question. On Earth, organisms breathe oxygen or exhale carbon dioxide. Here, microbes might metabolize hydrogen itself, combining it with carbon monoxide to release energy in a process called acetogenesis. Imagine entire ecosystems built not on photosynthesis, but on chemistry so exotic it redefines the very meaning of food chain. Predators in these depths wouldn't hunt prey. They might scavenge floating pockets of hydrogen sulfide or filter chemical gradients from thermal vents. Their biology could be so foreign, so unlike anything on Earth, that our most advanced lab equipment might not even recognize it as life at first glance. What makes K218b so tantalizing isn't just its potential to host life, it's the sheer commonness of its blueprint. Heisian worlds are everywhere in our galaxy, especially around red dwarf stars. If even a fraction of them have conditions like this, the cosmic census for life just exploded. Suddenly, we're not just hunting for Earth twins. We're staring at an entire category of planets where biology could be bubbling beneath hydrogen skies, utterly invisible to traditional searches for oxygen or chlorophyll. But here's the haunting twist: detecting life here might require rewriting our playbook. On Earth, we look for biosignatures like oxygen or methane. On a Heisian world, those gases could be meaningless. Instead, scientists are racing to identify new markers. Dimethyl sulfide, for instance, a compound produced by marine algae here, but which might signal something far stranger in the oceans of K218b. It's like trying to solve a crossword puzzle when half the alphabet is missing. The real gift of this world isn't just expanding the map of where life could exist. It's shattering the map entirely. K218b forces us to admit how little we truly know, and how much wilder, how much more inventive the universe might be than we ever dared to dream. Out there, beneath those hydrogen clouds, an entire chapter of biology could be waiting, and it's nothing like the one we wrote. Lighten's Starbee doesn't just orbit its sun, it exists in a cosmic time warp, a world where the very rhythm of life would feel alien to our Earth-bound senses. Imagine a planet so close to its dim red dwarf that a full year passes in just 20 Earth days. Seasons wouldn't crawl over months here. They'd flicker by in weeks, spring melting into summer before you could blink. Plants might shoot up like time-lapse footage, their life cycles compressed into frantic bursts of growth, pollination, and decay. Predators wouldn't stalk prey over seasons. They'd evolve to hunt in hyper-speed, their metabolisms tuned to a world where time itself feels accelerated. Now picture a civilization rising in this relentless cycle. On Earth, history unfolds over centuries, cultures evolving at the pace of generations. But on Lighten's Starbee, a single human lifetime could span 50 years, each one a whirlwind of environmental shifts. Calendars here wouldn't track months, they'd measure time in biological milestones, like crops planted and harvested a dozen times before a child learned to walk. Architecture might prioritize speed and adaptability over permanence, with entire cities redesigned between one orbital cycle and the next. Even language could evolve to prioritize efficiency, with words compressed to match the breakneck pace of life. The planet's tidal locking adds another layer of strangeness. One side forever burns under the star's crimson glow, while the other drowns in eternal night. But along the twilight terminator, where day meets dark, conditions might strike a fragile balance. Here, life could cling to existence in a narrow band of habitability, constantly migrating as temperatures swing violently between the scorching dayside and frozen nightside. Organisms might develop biological clocks utterly divorced from light cycles, tracking time through gravitational tides or magnetic pulses from their turbulent star. What makes Lighten's Starbee so revolutionary isn't just its speed, it's the way it forces us to confront time as a flexible, subjective force in the universe. We assume life needs long, stable eras to evolve complexity, but this world whispers a radical alternative. Intelligence might arise not despite chaos, but because of it. A species here wouldn't have the luxury of slow contemplation. Every advantage would go to those who think fast, adapt faster, and treat change not as a threat, but as the only constant. And that's the real gift of this frenetic world. It doesn't just expand our search for life, it shatters our Earth-centric view of time itself. Out there, in the whirlwind orbits of red dwarf stars, biology might dance to rhythms we can barely comprehend. And if that's true, then the universe's greatest minds might not be the deliberate philosophers of stable worlds, but the quick-witted survivors of places where every moment counts twice as hard. Teagarden's Starbee isn't just old, it's a relic from a time when the universe itself was still figuring out the rules. Orbiting a quiet red dwarf 12 light-years away, this ancient world has existed for 8 billion years, nearly twice as long as Earth. That's enough time for stars to be born, burn out, and collapse into black holes. Enough time for entire evolutionary sagas to unfold, fade, and begin anew. And here's what makes it extraordinary. Unlike most red dwarfs which erupt in violent flares, Teagarden's star is eerily calm. No atmosphere stripping tantrums. No deadly radiation spikes, just a steady, dim glow that's barely changed in billions of years. If life took root here, it's had the rarest gift of all, time. Picture the possibilities. On Earth, complex life took roughly 4 billion years to evolve from single-celled organisms to space-faring humans. Now double that timeline. What emerges when evolution isn't rushed? Maybe intelligence so advanced, it's transcended biology, altogether civilizations that have long since merged with machines or exist as pure energy. Or perhaps life here never needed to rush. With no mass extinctions from stellar flares or ice ages, evolution could have taken a leisurely path, refining species over eons until perfection. Imagine creatures with nervous systems so efficient, they process information at near light speed, or ecosystems where every niche is filled with organisms honed by unimaginable stretches of time. Then there's the climate, tidally locked like most red dwarf planets. Teagarden's Starby likely has a permanent day side and night side. But with such a stable star, the Terminator line, the border between light and dark could be a paradise of temperate balance. Oceans here wouldn't boil away or freeze solid. They might persist undisturbed for billions of years. Under those waters, life could have evolved solutions to problems Earth's organisms haven't even encountered. Maybe photosynthesis here uses wavelengths we can't see, or organisms draw energy directly from the planet's internal heat, creating a biosphere completely divorced from sunlight. But here's the haunting question. If life is here, why haven't we heard from it? A civilization with 8 billion years of progress could have colonized the galaxy 1,000 times over. Some theorists suggest such beings might have no interest in expansion, having long since turned inward to virtual realities or cosmic-scale art. Others propose a darker answer. Perhaps intelligence inevitably leads to self-destruction, no matter how much time it's given. Or maybe most humbling of all, complex life is rarer than we think, and this ancient world is just a beautiful, empty garden. Teagarden's Starbee doesn't just expand the search for life, it forces us to confront the limits of our imagination. Because out there, in the quiet dark, an entire alternate history of the universe might already be written, and it's nothing like ours. Ross 128b doesn't just orbit its star, it basks in a cosmic rarity, silence. 11 light-years away, this Earth-sized world circles a red dwarf so unusually calm, it barely flickers, no violent flares, no atmosphere-stripping tantrums. Just a steady, crimson glow that's remained unchanged for billions of years. In a galaxy where most red dwarf planets are battlegrounds, their surfaces scoured by radiation, their atmospheres blasted into space, Ross 128b is an oasis. A world where life, if it exists, might not have to fight for survival every single day. Picture standing on its surface. The sky hangs heavy with the deep red hue of Ross 128, a star so dim it casts shadows weaker than Earth's moonlight. Yet this faint glow could be the key to the planet's potential. Without the constant barrage of solar flares, Ross 128b might have held onto its atmosphere, creating a stable climate where liquid water pools in valleys shielded from the star's weak light. Tidally locked like most red dwarf planets, one side would bake in eternal twilight, the other freeze in perpetual night. But along the Terminator line, where day meets dark, temperatures could hover in a Goldilocks zone just right for life. Here's where it gets even more intriguing. Recent studies suggest Ross 128b might not be tidally locked after all. Its orbit could be slightly eccentric, enough to induce a slow rotation over millions of years. If true, this planet could have day-night cycles, distributing heat more evenly and preventing the extreme temperature swings that plague other red dwarf worlds. Oceans here wouldn't boil away on one side and freeze solid on the other. They could ebb and flow with actual seasons, their tides shaped by a rhythm not entirely alien to our own. The real magic of Ross 128b lies in its star's age. Red dwarfs burn so slowly they live for trillions of years, far longer than the current age of the universe. This means Ross 128 has likely been stable since before Earth's continents even formed. If life took root here, it's had uninterrupted eons to evolve, experiment, and perhaps even advance beyond our wildest imaginations. Imagine civilizations that have mastered fusion, harnessed dark energy, or even transcended physical form, all while humanity was still crawling from the primordial soup. But here's the humbling twist. Ross 128b is close. 11 light years is practically next door in cosmic terms. If we ever develop the technology to send probes to nearby stars, this world would be at the top of the list. Its calm star makes it easier to study, its potential atmosphere ripe for detection with next-generation telescopes. We might not need to speculate about its oceans or continents for much longer. We could see them. What makes this planet so transformative isn't just its habitability, it's the way it defies the red dwarf stereotype. We've grown accustomed to thinking of these systems as death traps, their planets roasted or frozen into submission. Ross 128b whispers a different truth. The universe always has exceptions, and sometimes those exceptions are closer than we think. So the next time you look up at the constellation Virgo, remember, there, invisible to the naked eye, drifts a world that could be proof that even in the quietest corners of the cosmos, life might be waiting, not with a roar, but with a patient, steady pulse. These 25 star systems aren't just cosmic oddities, they're glimpses into a universe far stranger and more inventive than we ever imagined. Each one defies the rules we once thought were universal, rewriting the playbook on where and how life could exist. Take the diamond-studded crucible of 55 Cancry E, where oceans of supercritical fluid churn beneath a crust of compressed carbon, or the tempestuous chaos of HD 80606b, where seasons don't gently transition, they crash together like tidal waves, reshaping entire climates in hours. Even the frozen, seemingly lifeless expanse of LHS 1140b might hide a secret, a global ocean locked beneath miles of ice but teeming with possibilities we've yet to fathom. What unites these worlds isn't just their strangeness, it's the way they force us to confront our own assumptions. For centuries, we've searched for life by looking for reflections of Earth, temperate climates, liquid water, stable orbits. But the universe doesn't care about our checklists. It thrives on diversity, experimenting with extremes we once dismissed as uninhabitable. Life, if it's out there, might not need a sunlit surface or a gentle breeze. It could be thriving in the crushing depths of a gas giant's atmosphere, or clinging to existence in the radioactive maelstrom around a pulsar. It might not even use DNA, water, or chemistry as we know it. The building blocks of biology could be as varied as the stars themselves, and that's the real revolution here. every time we discover another world that breaks the mold, a planet with triple suns, a moon orbiting a gas giant in the habitable zone, a rogue world drifting through interstellar space, we're not just adding to a catalogue. We're expanding the very definition of what life could be. The more we learn, the clearer it becomes. Earth isn't the blueprint. It's just one experiment in a cosmic laboratory that's been running for billions of years. So where does that leave us? Humble, curious, awestruck? The universe has shown us again and again that it's far more creative than we are. And as our telescopes grow sharper, as our probes venture farther, one truth becomes inescapable. The next great discovery won't just add to what we know. It will shatter it. That's the real gift of these 25 systems. They're not just destinations on a star map. They're invitations to wonder, to question, to keep looking up with the same wide-eyed curiosity that first made us point our eyes to the sky and ask, are we alone? The answer, it seems, is waiting in places we've only begun to imagine. And if you think this list has stretched the limits of possibility, just wait. The cosmos is only getting started. Don't forget to hit subscribe because the next chapter in this story is being written right now in the light of distant stars, and you won't want to miss it.